Hey, how are you doing? I hope you are good. In this video, I want to show you my home-built security operations center lab, a mini enterprise network running entirely on my Acer Predator laptop. Now, we've got a Windows domain, as you can see over there, and then we have an attacker box right here, Kali, and then we have a vulnerable web app, that's the VM machine, and this is the site. There you go. And then we have a full detection pipeline into Splunk right over there. I'll give you a quick tour of the topology and then show you live telemetry flowing from endpoints, firewall, and apps into Splunk. Now, moving over to the topology, there you go. Everything lives on a single routed lab network, 172.16.58.0/24, behind this OPNsense firewall. So OPNsense is our router, our intrusion detection system, and traffic exporter. And then we've got the domain controller that I showed you earlier. It has Wazuh agent, and then we've got PC1, which is our main workstation. It has Wazuh, Splunk Universal Forwarder, Sysmon, Fleet, Velociraptor, and Atomic. And then we've got PC2, which is just a test client. And then we've got Ubuntu, which has Juice Shop and Filebeat, Kali, another Ubuntu machine, which has Wazuh Manager and Filebeat. And then we've got Splunk, which is another Ubuntu machine, which has Splunk and Logstash and FleetDM and Velociraptor. So the goal is simple, right? Any interesting security event anywhere in the lab should end up searchable in Splunk. Let's start with pipeline A, Windows endpoint security. I'll switch over to PC1. Now, instead of just generating a random log, I'm going to simulate an attacker trying to blind the security operations center. On PC1, I have the admin rights. I don't want Wazuh reporting my activity, so I'm going to kill the sensor. I'm just going to run this command. Bear with me. And that's it. The agent is dead, and I've disabled startup. Right now, I'm operating in a blind spot, right? I could install malware, exfiltrate files, and the Wazuh manager wouldn't receive a single packet. Now, let's say an administrator notices that the service is down, or a scheduled task forces a remediation. Let's bring the agent back online. Right? The agent is back up. Now, let's switch over to Splunk to see. Now, an attacker might think that they got away with it because the agent was down, right? But if you would allow me to run this command, and there it is, a Wazuh agent started alert. In a real security operations center, seeing a critical security agent restart unexpectedly is a serve one incident. It tells us exactly when we lost visibility, allowing us to focus our forensics investigation specifically on that time gap to see what the attacker tried to hide. Let's move on to our next pipeline, application security. Here is our vulnerable web app, Juice Shop. As I interact with the site, logging in, searching for products, or attempting SQL injection, the application logs are being shipped in real time. Now, let me try login. I'm just going to use some bogus logins, right? I'm just going to type a random password. Nice. What I'm going to search, I'm going to search for, boom, cool. And then we can correlate the web activity instantly in Splunk. Let me run this search. There we go. Here are the raw application logs, right, coming from the web server. We can see the request paths, the timestamps, and the user interactions. But by combining this with the endpoint data we just saw, we can trace an attack from the web shell all the way to the system shell. Now, let's finally look at pipeline C. Even if an attacker manages to wipe the logs on the endpoint or bypass the web application logs, they still have to travel through the network. The OpenSense firewall is configured to ship Suricata IDS alerts and Zenarmor flow data directly to Splunk via UDP. Let's dig into the traffic flows using Zenarmor, and I'll just there we go, and there it is. Because we are passing the JSON directly, I don't just see a wall of text, right? I get the complete network story for every single packet. First, I can instantly identify the source, whether it's an internal IP or a host name. I know exactly who initiated the connection. Let's find that source IP, source host name. It's coming from the DC, right? And then second, I can see the destination. I can track exactly where that traffic is going, whether it's moving laterally or to another server or exiting out to the internet. Let's look for the destination IP. Looks like it's going to our our IDS, our router. And now, thirdly, I can get the context. I can see the destination port and protocol. This tells me immediately if it's safe web traffic or file transfer or suspicious remote connection attempt. It's total visibility right here in Splunk. Let's look for, um, and we saw the destination port earlier. IP destination port right there. There it is. And then, not Porto. Do we have a Porto here? Let's see. There it is. DNS. Great. So we have endpoint, app, and network logs flowing in, but a modern security operations center needs more than just passive logs. We need active defense, right? That's why I'm running FleetDM and Velociraptor on the same server. Now, over here, you see PC1 and Splunk. Fleet gives us the live queries. If we see something suspicious on PC1, I don't have to guess. I can instantly ask the entire fleet who else has this process running using simple SQL. And for deep forensics, we can use Velociraptor. While Splunk tells us that something happened, Velociraptor lets us go get the evidence. I can hunt for artifacts, pull the master file table, or dump process memory directly from these agents without ever leaving my chair. So this completes the loop: attack on Kali, detection on Splunk, and response in Fleet and Velociraptor. Just showing the diagram over here. But if you'd like a deep dive into any part of this, Wazuh rules, log slash routing, or those Velociraptor hunts, drop a comment below. And thanks for watching.